that works. I should know Dave's bio by heart by now, since I've been married to him for over 40 years, but let me run through it real quick for everybody. Dave just recently, about a year or so ago, retired as Senior Vice President and Chief Information Officer from Spartan Nash Corporation, a position which he held for 22 years. He had the responsibility for business systems, technical infrastructure, communications technology at Spartan Nash. In addition to that, he's had over 50 years of experience in information technology in retail, wholesale, manufacturing organizations. He also worked at Hewlett Packard and General Foods prior to Spartan Nash. He's taught classes at a university in Colorado when we lived there. And he holds a bachelor's degree in business administration and a master's degree in computer science, both from the University of Arizona. So I enjoy the class, and I'm going to turn it over to Dave.
Good morning, everyone. And I'm going to go ahead and put the slides up right now because I've got a lot of information, and no, it's not the Christmas deal. Hold on a second. The topic for today's class is how the internet works. So this is a huge topic. There's lots of directions I could go and so forth. So I tried to kind of walk a line so that I don't get too technical, because it can get pretty technical pretty quickly. But here's the format I've come up with. I just want to talk a little bit about how the internet was invented, a bit of its history, and some of the history will creep into the other sections as well, where I think it matters. And then I've broken it into 4 different areas. One is how we interact with the internet. In other words, so we're all today on this call, we're all using the internet to convene and communicate. And so how that's evolved and how that works and some of the different ways that you interact with the internet, I'm going to go through that. Then talk about how the whole network works, how information moves. And again, can be incredibly technical. I'm going to try and keep it as high level as possible, but yet talk about some of the key pieces that make it work. And it's an international network. So we're going to talk about how the whole world is interconnected. Then a little bit about how you find things on the network. So how technically things are found because of the millions of devices that are on the internet. How does one find a particular thing? How does the network know where things are? And then how do we as humans figure out where things are? And then talk a little bit about the processing centers that are behind the scenes that make all this stuff work. And a little summary at the end. So hold on a second, my screen's. Okay, so the history now, we're going to talk about what it is, a bit of a timeline, because this all started in the 60s, and a little bit about how it's administered. So what is it? So unlike the telephone network, which for years in most countries was run by a single company, the global internet consists of tens of thousands of interconnected networks that are run by service providers. They're run by individual companies. They're run by universities, governments, and others. And so it is a huge network, and there are lots of people, lots of constituents, if you will, that help make it work. And then one of the most important things about this network is something called open standards. We'll talk a little bit about this in the history. There was a particular individual that came up with this concept of having it be open, meaning that there's no one government, there's no one institution, there's no one company that controls the internet. And so the standards and how we interact in the network is all controlled by a consortium of people and organizations that collectively come up with ideas. So there's no one controlling entity and there's no one controlling company. Because of that, it makes it possible for anyone, literally anyone, to create content, offer services, sell products without requiring any permission from any central authority. And so that has some negative aspects to it, but it is one of the things that makes it such a huge success. So who's in charge of the internet? No one is, but yet everyone is. And you'll see when I talk a little bit about the administration of how that works. So how it started, a little bit about the history. So there's an agency within the government called the Advanced Research Projects Agency, and it's a division of the Department of Defense. It was founded in the Eisenhower administration in 1958. And over the years, it's had many areas of focus. One of the original areas of focus was rockets and space exploration and so forth. Both for military and non-military purposes. And that became such a big deal that over time that spawned NASA and was basically pulled out of ARPA. A second thing that we're all familiar with was originally called NavStat, but it was a predecessor in what became the Global Positioning System. So GPS that we're all accustomed to and has helped us in our everyday society. That all came from the ARPA agency as well. And then one of the things that they've through the research that they've done, they've contributed many things to computer science. But excuse me, one of the big things was ARPANET, and we'll talk a little bit about that. You may, if you read the literature today, you'll hear it referred to as DARPA or DARPA for they put defense on the front. It was renamed in 1972. Same organization, but they changed the name. So depending on what you read in the literature, you'll see both names referred to. A little bit about the history. So there was in the computer science, and if you've studied computer history, which I've done a great deal of over the years, there's a it was an individual early on, 1962. He worked at MIT, J.R.L. Licklider. His nickname was Lick, and Lick was a big thinker. And he proposed through a series of memo at MIT back in August '62, this thing he called the galactic network. Now you got to keep in mind that back in those days, there were barely 1,000 computers. I didn't do the exact research, but computers were slow. They were used for research. There was little use in business. It was very, anyhow, there just weren't a lot of them. And so he started at MIT, but then he became the head of the computer research group at ARPA in October '62. There's another individual that came up with something called packet switching theory. We'll talk a little bit about that, but the essence is in the old days, if two computers wanted to talk to one another, you stretched a wire between the two, and and that would just be one wire, and they could only talk to one another. If you wanted to have three computers talk to one another, you stretched a wire between computer number one, computer number two, computer number two, computer number three, and computer number three, and computer number one. And it was only that way that they could talk to one another. And so packet switching theory came up with an idea that we could have this intelligent network and have one connection on a computer and have it share information. And we'll see some more about that. So the ARPANET was founded in February 1966. The first email was composed and sent in 1971. And then an individual by the name of Robert Kahn was the individual who came up and said, we shouldn't let any one company control this thing or one entity. We need to have an open architecture so everybody can contribute. So that was a very key tenet early on in all of this. Then there was another significant event, and this has facilitated things on the internet, and it affects all of your lives. Anybody watching this is affected by this particular technology. And that was there was an organization at Xerox called PARC, P-A-R-C, for Palo Alto Research Center. And there was an incredible number of very significant computer inventions that came out of PARC. And one of them was the Ethernet local area network. And if you have a wired computer plugged into a router in your house, you're running the Ethernet network. And so we'll talk more about that. So then the other thing, and if you read literature, you'll hear about a man by the name of Vint Cerf, often referred to as the father of the internet. Robert Kahn from the open architecture guy, and Vint Cerf proposed TCP/IP in May of 1974. TCP/IP is a language that allows computers to talk to one another. And it is the language of the internet, and it is now kind of the language of computer communications worldwide in general. So that was very significant. And so that was a key milestone. Then we're all accustomed to looking at websites that are .com, .org, .gov. In certain countries, you might, if you're in Germany, it's .de at the end. and so forth. And that whole concept of domain structure and that naming was invented in October of '84. Another very significant thing that everybody on this call uses is two things. One's called hypertext, and the other is the World Wide Web. And this was invented by an individual who worked at CERN, which is a European research center. They run the Hadron Collider, and he came up with an idea of how to present information on a screen and to navigate using a browser. And the first real browser was created called Mosaic in 1993. And we'll talk more about that later on. And this next one is a little bit obscure, but I thought it was important to point out. So this first socket layer thing in 1994, the significant piece there is that all this stuff up until this time really didn't pay a whole lot of attention to security. And so this was the first sort of milestone in the development of the internet of security being really a concern. And so this was a way that you could have communication between two computers and have that communication be encrypted. And again, we all use this today in various websites. You don't necessarily know it, but it's out there. But you hear all this information about hackers and whatnot. And part of the problem of the internet was back in the 60s and the 70s, people didn't worry a whole lot about security. I mean, there weren't that many computers, there weren't that many communication lines. It wasn't a big deal. Well, now it's turned out to be a big deal. And so there's an enormous amount of security that's now been built in that was never there before. Another significant piece is the first internet phone call was placed in February of 1995. That was very significant. So those are some of the major milestones, but it gives you an idea of some of the timing of when some of these things happen. Now, what I threw up on the right-hand side of the chart is a bunch of names of companies that you all know and when they started in all of this. So Yahoo started in 1994, Amazon, just selling books initially, came into being in July of '95. September, Google started, and back in September of '98. At that time, though, Yahoo was the search engine. And we'll talk about search engines later. One of my favorite sites in 2001, January 2001, Wikipedia was started. And Wikipedia is an incredible resource. And again, one of my favorite. When I bring up my browser, there's always a Wikipedia window that's there. Facebook started in February 2004, YouTube started in 2005, and Twitter started in March 2006. So those are just some of the kind of the milestones of different events that occurred that started this whole process. That ARPANET network that was built in 1969, that first map that you see on the upper left, you can see there were 4 computers that were attached. By 1973, you can see there were quite a few more. And by 1982, in the lower bottom section, you can see there were quite a few computers attached. But again, it was just infinitesimal compared to what it looks like today. So a little bit about who runs the internet. So I'm not going to go through this in detail, but there are about 11 different organizations that govern the internet. Again, no one country. Almost all of these, and you'll see down the either side of this this graphic, that list off different organizations. Those organizations have representatives from major countries around the world. And so one of the things that happened early on in the internet is there was a lot of criticism that the US controlled so much of it. And all that has changed now. So there's representative in these various committees that control and write the standards for how and do the research of what it's going to be like in the future and so forth. So, but in the center, the important thing to understand is you'll see 4 steps. And the lower step is from the various stakeholders from around the world. There's a lot of communication and discussion about issues, depending on what the topic of the issues are. And there's a lot of open debate. And that open debate then forms into strategies or concepts or ideas of how we're going to, it's going to grow. And so how do we deal with the growth? And what kind of standards do we have in terms of policies and what we permit to happen and what we don't permit to happen? And it just keeps bubbling up until the end, and until it gets operationally implemented and everybody agrees to it. And how, and all the players that contribute to running the internet implement the ideas and the concepts and the policies and the standards as they are created through the process. So that's how it's managed. It's not one organization. It's not one government. It is a group of, many cases, very technical, very, very intelligent engineers and folks that are grappling with sometimes little infinitesimal things that might affect how you do things on the internet, but they're the ones that are making it happen. But it's a international effort in terms of how it runs. So with a little bit of that background, I'm going to break the conversation into 4 pieces. The first piece is how we interact with a network. And then I'm going to spend a fair amount of time just talking about that evolution, how that's happened. We'll talk about how information moves on the network. This is an incredibly technical subject, and I've tried to boil it down and make it as simple as possible. Talk about the processing environment, the enormous amount of resources that are behind the scenes that make all this stuff work. And then we're going to talk a little bit about how you find things on the network. First of all, how the network itself negotiates and finds things when you do certain things at your keyboard. And then what we do as human beings when we want to find information and how that all happens. So those are going to be the 4 topics. How we interact. How we interact with the internet has evolved a lot over the years, and many of the things that have influenced, I call it the human to computer interface, how we as human beings interact with the computer and the network. There's been many things that have influenced that. One is computing power, the processing power from computers versus those early years. It's astronomical how much that's changed. And that's a topic in and of itself. The personal computer and its evolution has changed how we interact with the network. And then speed of communications. And we'll talk a bit about fiber optics and what that has done for the speed of communication that makes things possible, like streaming a movie that you can watch on TV at night that was never possible back in the 70s. And so forth. The cell phone or the cellular network, its impact on how we access information on the internet, and then sort of things that are happening now of other methods of human interaction that have come along that are now affecting our everyday lives. So how did it start? Back in the late 60s and early 70s, it started with a dumb terminal. You type something on a keyboard, you read characters on a screen or a piece of paper. It was very slow, originally about 10 characters per second. I couldn't resist this. The picture of the terminal on the far left, when I first wrote my first programs in 1968, that was a teletype ASR 35, and you had these incredibly mechanical keys and yellow paper, and it would print information on the paper at the rip-roaring speed of 10 characters per second, which meant to print a line of, I don't know, 100 characters or so, took about 10 seconds just to write a line. It was very mechanical, very noisy. Then in next version of that was a deck writer. This is what I used in college from the Digital Equipment Corporation. And you had CRTs later in the 70s, but again, they're running very slow. It's painting the screen and you watch the characters come on the screen. So that's how it all started. Then the personal computer came along in the late 70s, early 80s. Access to the internet was still just a dumb terminal. And so you were typing and reading information on the screens. There typically wasn't any graphics. It was still slow. It was faster, but it was still slow by comparison to what we experience today. It was about 90 characters per second. So it would write a line on a screen about every second. So again, very, very slow. Then the graphical user interface came along, and I mentioned the Park Research Center in Xerox in Palo Alto. They invented the graphical user interface. Many people associate that with Apple and the first Macintosh, which you see on the right, but Park actually did the invention. And Xerox, they had a terminal, a star terminal. There was another one, I can't remember its name. But they were only in research institutions and never made it very far. And the bottom line I always used to say is Xerox could never get past being a copy company. And so they did some amazing things out of their research centers in developing computer equipment and concepts and technologies, but they just couldn't monetize it and turn it into a business. And so, in general, people don't think of Xerox when they think of computers. At this time, many internet functions were still character in nature, but at least you now had a mouse to navigate the screen. Things were getting faster and so forth, but it was still pretty rudimentary. But then came along this invention of hypertext and browser technology. And so I'll differentiate the two. And you can sort of see it in the graphic in the middle. If you are on the internet and you look at a document and there's the written word, and every so often you'll see a word that's highlighted, and you click that highlighted word, it takes you off to a different page. That is called hypertext technology. And so you can have a long dissertation and many words will be highlighted, and it allows you to go and okay, what's that word mean, or what's that concept mean? You click on it, take you to another page, you read about it, and then you can come back. So that's hypertext technology. Second one is the browser. And the browser was the way, and Mosaic, you can see on the left, was one of the first browsers that came out. I kind of like the graphic on the right, you deserve a better internet. But the whole idea was to have a graphical interface to the internet that was much more responsive. It was much easier to navigate and very powerful. And that's what we use today. And so if you look at the bottom there, you'll see all the common browsers. So the first one is Internet Explorer, which is a Microsoft product. Its next generation is called the Edge. That's the next icon. Firefox in the middle is an open source browser that's very common. Then the next one you see is Safari from Apple device. You'll see that icon on your iPhone or your Mac. And then the last one is Chrome, which is a Google product, and you'll see that on Android phones. And many of these products, you can, whichever brand of computer or phone that you have, you can install these browsers, and they all have various features and compatibilities and so forth. But that is how we most typically interact with the internet today. And so the way that works is you type in a URL. And so, for example, if you type in Google, www.google.com, www is the worldwide web domain. Google is the domain name. And then the high level, as we talked about before, .com, .org, .gov, et cetera. You type that in, and the browser, and we're going to find out a little later how the browser figures out, well, where the heck is that? And then sometimes you'll type in HTTP or HTTPS. That's actually the protocol. It's Hypertext Transfer Protocol, HTTP, that was invented as part of the whole browser concept, which allows you to have video, graphic images, characters, video, all sorts of different information and ways of presentation on the screen. So the URL is very key, and knowing URLs is very key. And in the early days of the internet, just all you knew, you had to know URLs. There wasn't an easy way to find them. Yahoo came along and it provided the first search mechanism. Google's kind of the dominant player today, but there's many more, and we'll talk about those later. So that browser technology, you're on your machine and you type in that URL on your machine, and it sends a request off to a server, and the server, in the simplistic case, the server comes back and presents the page to you based on what you addressed. And you can see at the bottom, the HTTP, that's the protocol, that's the language that the browser used to talk to the computer and give you a response. And the HTTP protocol defines how, it's like a language, it's how we communicate, how the two devices communicate with one another. And so this dramatically increased access on the internet, and dramatically improved the interaction for us as human beings with the computer. And in the common browsers, you can see them listed. I talked about them on the other page. Now I put this page in for my wife because she loves to point this out, and she's absolutely right. The other thing that's really helped us as humans work with computers and make things much more compatible is standard file formats. So back in the day, a program would create a file, and unless you had that program, you couldn't read it. Well, then came along Microsoft Office, and you had spreadsheets, Excel, you have Word for word processing, and you have PowerPoint, which is what I'm using today. They had standard file formats. And so with the pervasiveness of Microsoft Office, and then later the Apple suite, and they have similar set of products, these file standards started to become very dominant, so that when we move files around and want to share information with one another, something created on one computer can easily be read on another computer because we have the same file formats. And there's other file types down at the bottom there. You see PDF. If you have a document you receive, that's an Adobe standard. We exchange documents and they're PDFs, and all these tens of thousands of millions of computers can move PDF files around. We can all read them. You can scan on a HP printer or copier. You can scan a document, it'll create a PDF for you, or JPEG if you work with photos. JPEG is a standard for how you encode a photo and store it on a computer. And PNG, that's another graphic. There's lots of file types, but these dominant applications and these dominant file types have made it very easy for us as humans, as we work on computers, to share information. So most people wouldn't bring this up, but I think it's very germane to the situation. So then, now the device continues to expand. So now we have tablets, and some of you, I know from watching Zoom calls, many of you watch them on your tablets. And so there's tablets, there's Microsoft has a Surface, which is a tablet type computer, and of course cell phones. And cell phones, these devices are very portable. They're very flexible. And so again, it's made accessibility anytime, anywhere is dramatically improved it. And then apps come along. And so apps, if you're a computer person, it's an application. But that's a program that runs on your device. It runs on your iPad, it runs on your phone, but it allows a much more sophisticated way to interact with us as a human being, to interact with the information, and in turn the internet. It can provide a lot of function, and the app might be very sophisticated or it might be very basic. But in any case, it's typically interacting with a database back on the server, back with a service provider. And I saw Wally Foo's name. We're both into wine, and there's a great wine application called Vivino, and they have this enormous database of wine labels. So it's an obscure thing, but if you're into wine, that's the thing. So if you look at the utilities here, I just kind of had some classification of types of utilities. There's all types of apps. There's thousands and thousands, hundreds of thousands of different apps for different platforms. Some of them are lifestyle, some are social media, utility purposes, games, productivity, information, and so forth. That news should be news, but anyhow. So that has dramatically changed the interface of how we interact with the internet. Now, voice is the next thing. So voice devices, and these are all different types of voice devices. On the left, you see Siri. At the bottom, that's a Google Show. In the middle, that's Google. Those are Google devices. The lower right is an Amazon Alexa. And so these devices now allow you to just ask questions, and because of the processing power behind all of it, not in these devices just convert it to packets of data that get sent back to data centers where they process the information. I always joke that in our house, I'm still kind of an old school. We'll be sitting around at dinner and talking about something, and somebody, well, how old is so-and-so? And so I'll pick up my phone to start looking out. My wife, being the smarter of the two of us, just asked, hey, Google, how old is so-and-so? And has the answer before I've even been able to type it in. So anyhow, again, dramatically changing how we interact with the internet. And then now we're kind of a tech household. We have all of these, and these are just a sample. I think we have maybe 50 devices on our network. So you can buy watches that are interconnected to the internet. You can buy a stereo system that interacts with the internet and can stream music. Many of us have these intelligent thermostats that allow us to use the internet to get weather and control the temperatures in our homes. You might have a camera system. And another popular thing is TVs and movies, streaming TV shows and movies, people wanting to cut the cord and all of that business. Actually, it looks like I chopped off the Apple TV. And then in our house, we have a sprinkler system, and our sprinkler system controller is on the internet. And so I have an app on my phone and can control the internet or control the sprinkler system basically from anywhere. So, and there's many more. The point is as the human to computer interface has changed on the internet, this network and all this processing power now is available to us to be used in so many ways. So that's a little bit about the interaction and how you interact with the network. So now let's talk about how it actually moves. And we'll talk about sort of in your house or your building, how it locally, regionally, and nationally. Now, one of the problems here is I can show you some diagrams, but this thing is so huge, it's not like I can put up one diagram. I'll show you some different maps and so forth, but it's difficult because the thing is so large. So the first thing is, how do these things talk to one another? The language of how computers communicate, it's just like humans. Some humans know English, some know French, some know Chinese. There's lots of different languages in the world. Computers communicate in protocols. And it's a set of rules, how messages are sent back and forth between the computers so that they understand what the request is. And so in the 70s and in the 80s, in the 60s, the networks that existed, they were proprietary networks. So if you were an IBM shop, you typically ran SNA. If you were a digital equipment shop, you ran DECnet. If you had certain types of equipment, they ran the XNS protocol. But they were all controlled by companies. And so the whole concept with the internet is we don't want any company or government controlling what's going on. And so as I talked about earlier, Vint Cerf and Kahn came up with this concept and this technology called Transmission Control Protocol and Internet Protocol. So it's a set of rules. It's the language of the internet. Any of the devices, all the devices I've shown you, in order to communicate on the internet, they need to know TCP/IP. So whether it's your watch or it's your thermostat, there is a computer in there that knows TCP/IP that is necessary to be able to communicate on the internet. So the catch with this, and a couple different diagrams here, it's a packet network. So if you look at the upper diagram, you'll see a computer sending out 3 different packets, green, blue, and orange. And because of how the internet is built, those messages, those packets, those portions of the TCP/IP protocol can get routed in different ways across the internet. So you can see the green packet, it takes one route and kind of, I'll call it, goes north and works its way over to the destination computer. The next packet, the blue packet, it takes a totally different route. And the orange packet, it takes yet a totally different route again. And so what you see is in the lower left, you'll see that each of these devices interfaces to the network, and it has a IP portion that is processing the information and doing certain functions, and a TCP portion that's doing different functions, and it's interacting with an application at the top. So the application might be a web browser, it might be email, it could be a variety of different things, but just showing these one is that there's a copy of TCP/IP on every one of the computers that allows it to interact on the network. So that's very, very important. And TCP/IP, again, I got to be careful here because I don't want to get too technical, but the physical layer, the lowest level of the software that's running on the computer and the hardware is you have to convert those characters, those messages into electric signals, whether they're fiber optic signals on a cable or whatever, but there's a local area network that it's attached to. And so the hardware has to convert it to this electrical signal. You could work one layer up and it takes the characters and puts them in a packet, does some error control in case there's a problem, and puts it on that physical layer. Above that is addressing and ways to route packets. And we'll talk about addresses and about how that's handled. And then above that is the transport layer. And a perfect example here is maybe you have a screen that has 200 or 2000 characters in it, but the network can only support a message that's 500 characters long. So the TCP/IP layer will break it into 400 or 500 character packets and then send it down through the process to the other side. And then on the other side, the TCP/IP layer will put those 400 or 500 character blocks back together. So the application layer gets your email or gets that screen and so forth. And so you can see how through these various layers and these various functions, information flows. Again, we could spend a couple days on this topic. And so it's, again, just trying to talk at a high level. So if you have all these millions and millions of devices, we need an address. How do I know what device is where? And how do I talk to, if I want to talk to a computer in San Francisco, I need to know its address. And there's two levels of addresses. There's addresses for local networks, and think of that as your street address. So you have a house number and a street. And then there's global addresses. And the global address is you have a zip code and you have a country. And so with those three things, I can put together enough information that I know how to get from one address or one place to another. Now, it's a little bit different, but from an analogy standpoint, that's how it works. So the local area network. Each device in a house, now we have a large network, but every one of you is running a device on a local area network. You might have an iPad that is talking on a Wi-Fi network to a router somewhere in your house or apartment or wherever you live. Or you might actually have a PC that has a wire that connects into a switch that is a local area network. Each device on a local area network has an address. It's called a MAC address, or Media Access Control address. You see it over there on the right. And it consists basically of 6 sets of characters. And those characters are assigned in the hardware. So when Apple manufactures that iPad or somebody manufactures that computer, it has that MAC address built into it. And it's worldwide unique. And so the way that structure is those first 3 sets of characters are identified by an organization. So if you have a Dell computer, you have a particular number that is assigned to Dell, and all the Dell devices get manufactured will have that address in them. Or if they need more, they'll have several numbers that are Dell only, or IBM only, or Apple only. Then the second set of letters are numbers and letters represent, I call it the serial number. So Dell builds a computer, and so it has that first set of characters identifies as a Dell computer, and then the second half identifies it as, if you will, a serial number of that computer. So the way that you express that is you look over on the left, and you'll see the 7 computers there, and they all have the same address. I just whipped up an address. It's nothing, but the thing that's unique is the last digit of each one is unique. And so no 2 devices on that network have the same address. Everybody who are listening to this today, whatever device you're using has a MAC address, and that is how it's talking to your router and going out and talking to Zoom and so forth. And so if you have a router or you have a PC or you have a different device, sometimes you can turn it over, and on the nameplate, it'll have the MAC address on it. So actual local area networks, what do they look like? Again, you might have some sort of router. Residential networks are relatively simple, except for our house, but most houses might have 3 or 4 devices, maybe a laptop, maybe a desktop computer, maybe a thermostat, or maybe an iPad. And then there's a router, and we'll talk about that later. And maybe there's Wi-Fi, or maybe you're wired, and you connect up those devices. Maybe you have a printer. And so that local area network then talks to a router and then talks out to the internet. So multi-tenant housing is more complex. Business and schools networks are more complex, but it's all based on the same concept. So we talked about local addresses, those MAC addresses. So then, in order to talk on the internet, we need that global address. And so in that IP language, there is an internet protocol. And so the internet protocol address, and I'm not going to go into all the details here, but something to identify is that the original IP address concept was developed in 1970, and there were basically 32 bits or 32 binary bits that represent an address. And that was sufficient for about 4.2 billion addresses. And they thought, hey, this is no problem. But the way they structured it, and I'm not going to go into it, but how they handed out these numbers, they used them up pretty quickly. And so in the 90s, they realized they needed to develop a larger version. And there's something called IP version 6. I'm not going to try and express the number, but it's 128 bits is the address. So they went from a 32-bit address to a 128-bit address. I dare any one of you to try and express that number, the capacity number there, but it's basically 3.4 times 10 to the 38. It's a huge number. And so the belief is that it's not going to be exceeded. And you can see in the lower right, a Google IP4 address, you can see that first one expressed. And then there's the lower one is the IP6 address. And when you see 2 colons together, that means the numbers are all zeros. But anyhow, point is it's very big. And but it means that routers and hardware throughout the network have to be changed. So it's a very slow migration to move to this new address. But again, internet protocol address is how everything is routed around in the internet. So going back to that little local area network example, we still have our devices on our network that still have those MAC addresses that you saw before, but now there's another address that's assigned. It's the IP address. That's how we're going to be able to communicate across the internet and talk to other devices. And those addresses are typically assigned by your router. So if you're watching this on an iPad or watching this on a computer and it's talking through your router, that router has assigned a particular IP address to it so that your device can go talk to Zoom and Zoom can talk back to that device using that address. So how do we access the internet? So if you look at this, you look at the devices on the left-hand side, you can see that there's lots of different types of devices and they communicate different ways. Some of them use cellular communication, some use Wi-Fi communication, some use a local area network communication. Over on the right, you see the internet, and the internet can be brought to you can interact with the internet in lots of different ways. There's a product called Uverse, which utilizes the old phone line cables that some people use. It's a bit slower, but it's the old copper phone cables that are in the ground, but they are speed limited. Then you can go to your cable provider, and they've adapted the cable TV systems to run at much faster speeds. Or in the case, we have a condo down in Florida, and it's a building, or it's 4 buildings. It's 204 condos, and they wired the buildings all up with fiber. So we have fiber directly to our condo. If you're in a remote location, you might get your access through microwave. If you're in a really remote location, you might get your access through satellite. Or if you're in a metropolitan area, there might be Wi-Fi that's available, for example, in downtown Holland and other municipalities, and or cellular. And so cellular communications allows you to get internet access on your phone, on your laptop, on your watch, and so forth. All of these things require a router. And so that router is the interface that connects these various in the case of the LAN and Wi-Fi, makes these connections into whatever service you've whatever's provided to the building that you have access. If you're out walking around, you're typically using cellular as an access, and in the cellular case, the router's actually back in the cellular network. So anyhow, there's lots of different ways to get access to the internet, and they all have varying speeds. They have all varying performance capabilities. And what we've seen happen is over time, the speed of communications on the internet has increased dramatically from back in those days that I talked about in the early days, which has allowed us to stream movies and allowed us to have live interaction like a video conference, what we're doing right now. That wouldn't have been possible in the past. And so providing that high speed communications, and again, we can drill into lots of detail, but it's fundamentally altered how things work. So the fundamental thing that makes all this stuff work are something called routers. We all have a router in our house. I call them the traffic cop of the internet. They route data from one network to the next. They are what connects all those thousands of networks to one another. So in order to connect one network to another, you need a router. They make decisions based on that internet protocol address that we talked about. And then they use tables. And I like to say that those tables sort of represent a distributed map of the internet. But this is how it all works. The routers are the essential thing that make this all work. So when you see this diagram, you see the two red lines and the two round circles, those are routers. And so you can see in this particular case, we've got 4 networks, we've got 3 routers, and they make decisions about how to move the data around. And so if you look at it in more detail, and this is very simple, routers make decisions based on routing tables. Tables might be built, the engineers might set them up, configure them, or the routers talk to one another and say, well, I'm connected to so-and-so and connected to so-and-so, and they build tables inside that tells them what to do. So in this little simple example, we have a message en route that we want to send to A4. And so when we present that message out of route into A1, A1 looks it up and says, oh, I've got a message that wants to go to A4. And so it looks up on this destination table in the upper left there and looks up and says A4, oh, the next hop is A1. Now it turns out in this simplistic case, all the next hops are A1, but doesn't matter. So it sends that message to A1. And so A1 looks at it and says, oh, he wants to go to A4, and looks at the destination map on the right there and finds A4. Oh, the way to get to A4 is A3. And so it sends the message off to A3. Now, in the case of A3, it only has one place to go. So it looks up the destination and says, oh, A4, send it to A4. And so that's, in the simplistic case, how routers make decisions about how to route packets. And so if you extrapolate that and talk about the IP address talks about a destination. It has a network in it. It has a host in it and so forth. So the router, a little bit more technical description is when the router gets a packet, it looks it up and says, is the destination directly connected to me? In other words, is this network right like in your house? Is that a device I know? If it is, it does what the table says and handles it appropriately. If not, it says, do I know this host? Do I know this particular device? Do I have a route in one of my tables somewhere that tells me where it is? If it does, it says, okay, follow that route and send the packet off in that direction. If I don't have a destination in my tables for that host, but I have a destination table for that network made up in that number, then I look it up and I find it in my table and say, okay, what's that route say? I send it where it needs to go. And then if you've gotten all the way down there and you still haven't found it, in other words, I don't know the host, it's not directly connected to me, and I don't know the network, do I have a default network where I can send it? And if so, I send it to that default network. If not, then it gets the packet and sends a message back, says, I can't even get that. And sometimes if you do something on your internet and you type in an old address, sometimes you'll get that message that says, the router says, I don't know where to go. So routers come in all forms. There's small business routers and home routers. Probably everybody on this call should have a router that looks like something like one of these up at the top. Large businesses and some, you can see most of them also have Wi-Fi support in them. So whether it's a local area network where you have a cable plugged in, or you have Wi-Fi, the routers support that. And then, or there's large businesses, these are much more high performance routers, or then there's the carriers like Spectrum, Comcast, BPW. They have super high performance, very expensive routers. One of these devices could cost $100,000, and it allows you to interconnect many networks. It can process packets incredibly fast. And largely the internet, our homes are, you see up at the top. What's going on behind the scenes are devices like the ones at the bottom. So, and again, I'm not going to attempt to put up a network that represents the whole environment, but routing through a network, you can see in this particular case, I don't know, we've got 12 or so routers connecting different networks. And so those routers are routing those packets around. So if one computer wants to talk to another, the routers make sure that TCP/IP packet works its way back to the computer that it needs to talk to. I'm going to spend just a short minute on firewalls. Firewalls are a network security device that controls what can come in and what can go out of a network. As predetermined security rules, this is this can be a multi-day topic just by itself. It typically establishes a barrier between a trusted network, your house, and an untrusted network like the internet. Your router that you have in your house that you're talking through and listening to this today has a built-in firewall, and that firewall protects you from people that are trying to get in and look for weaknesses in the internet. So, and businesses use these technologies to control them, to manage themselves and so forth. In fact, this is an example of a business that I was involved with. And if you look at the diagram, we had vendors up at the top there that we would allow access. We had a firewall for them to get in. We had 22 distribution centers around the country. We ran a firewall to protect ourselves in case somebody did something on a computer in a distribution center that might cause havoc on our network. Retail stores, we had 170 retail stores. Again, somebody could take a memory key and plug it into a computer and introduce a virus. The firewall would protect the rest of the network. We had manufacturing plants. On the lower right, we had service centers, basically office buildings, and we had the PCI, that's our credit card processing system. And below that, you'll see HIPAA. We had 90 pharmacies. And so we use firewalls extensively to control what things could flow between the different parts of our network. So let's talk about how all this stuff gets moved. So this is a logarithmic scale, but if you look back in the 70s, there were maybe about 10 internet devices. Then you look in the 80s, and it got up to about 1,000 devices. And then you get to 2000, and if you look over there on the left, there's about 100 million devices. You get to 2018, and we're at about 1 billion devices. So the point here is the growth of the internet has been dramatic. And in order to do that, how can you support the growth and the speed to make all that happen? Here's another graph that I thought was quite interesting that shows the number of users in the world by region. That's a conversation in and of itself. You can see we're like the third one up on the bottom. But the point here is the dramatic growth of the internet and the number of computers and the speed and the complexity of trying to move all this data around. So the key to that was fiber optics. Fiber optics is how the backbone and many of the interconnections work. And so, and if we were physically here, I'd pass around some fiber optics because we installed a lot of it. But basically, it's a piece of glass that you send light down, and you do a lot of different things. I'm going to very much simplify it. You can turn the light on and off to represent bits, or you can change colors, and you have a blue light and a red light and a green light. And so you can have multiple conversations on different light colors going down the internet or going down the fiber optics, and it runs at the speed of light. So it's incredibly high performance compared to the old copper connections and phone lines. This is incredibly fast and allows all this stuff to work. So you see the design in the upper left. In the lower left, you see a large fiber optic cable. The fiber itself is about the size of a piece of human hair. In the upper right, you see some individual fiber cables that are used to interconnect things. And in the lower right, you'll see a piece of equipment in a rack and with tons of fiber optic connections all coming into it. And the speeds, again, have gone up incredibly over the years with fiber optics. That's allowed, and one of the cool things about fiber optics, and you can put the fiber in the ground or under the ocean or whatever, and as the electronics get smarter and as the engineers improve the electronics, you take the electronics off and replace them, and all of a sudden that fiber optic connection is running 10 times faster or 100 times faster. And so it's allowed these companies to be able to support the growth in the internet by putting the fiber in the ground and then just upgrading the electronics over time. So what's it look like? So again, I can't put up a specific map, but we'll take a look at some of the pieces. So if you look at it, they have a hierarchy of how they interconnect things. So the backbone of the internet is the highest level and where all the traffic is, like the freeway. And then there's regional things. Regional might be Michigan, or it might be the Midwest, and local might be Holland or Grand Rapids. And so as we these different companies that own the different parts, they hook the backbones together, and then regionally they make different connections into different backbones, and then locally we make different connections. And sometimes you have a single connection, sometimes you have multiple connections. But it's tier 1 is the backbone, tier 2 is the regional, and tier 3 is the local. And so it's those interconnection points that allow this thing to work. And so what I just for fun, I thought I'd do is put up, here's all the tier 1 internet carriers in the world. Now, not certain ones aren't listed. You might say, well, gee, China isn't there. And the reason is this particular list that I found was ranked by number of connections. And so Lumen Technologies, which you probably never heard of, they have 750 fiber optic miles laid in this country, down freeways. You know, if you drive from Kalamazoo to Grand Rapids on 131 on the east side of that freeway, there are tons of fiber optic cables that have been, I'd say tons, there may be 10 or 5 fiber optic cables that have many strands of fiber that AT&T and other people have installed over the years. You can see Italy, India, Sweden, lots of different countries. The names that you might know are Verizon down there at the bottom, AT&T. You can see they have 500,000 miles, 410,000 miles. Again, the reason they're on this list is because of the number of connections they have, not necessarily because of the route miles. And then you'll see sometimes it says a purchase or a question mark. Question mark is the particular company that did this research couldn't get the data. Purchase means is they purchase capacity on networks from others. So here's what the US internet backbone looks like. So you can see a big concentration in the East and the Midwest. It's more sparse out west. And if you spend time going around, there's cables buried along I-80. I mentioned the one on 131. Sometimes they're buried along railroad tracks where there is existing paths. The various companies that install these cables take advantage of the paths. There's also an international infrastructure to interconnect other countries. So there's an undersea cable network. Each country's infrastructure varies widely. Some of them in the more restrictive countries are controlled access. They all talk about the giant China firewall that limits access to the Chinese population to the outside. That's a whole topic in and of itself, but it's international infrastructure. As of 2020, there were 407 undersea cables in use. They're various capacities, and they're owned by, many cases, by telecommunication carriers. But nowadays, as they become so large, Google, Amazon, Microsoft, Facebook have all installed their own cables. And if you look at the cutaway there on the right, you can see a lot of steel wires. This is a very rugged cable. And the reason is as in general, cables will have faults. And if you look at 100 faults per year, 38 of them, 38% are fishing. So some fisherman gets a net or something tangled up in a cable near a continent. Anchorage, 25% are some ship drags an anchor over and interconnects with the cable. Abrasion, there's even cases, there's a video out there of a shark taking a bite out of a cable. Didn't hurt it, but so laying an ocean cable, you can see in the upper left, sometimes they're just laid on the ground on the ocean. Other times the ship drags a plow and lets the red fiber optic cable come down to the plow, and it plows it into the ocean floor. You can see down below on the left a ocean laying ship. You can see that big round area in the center. That's where all the fiber optic cable is coiled up because it's one big piece. You look at the upper right, there's a guy that's either loading or unloading fiber out of the storage compartment in the ship, getting ready to be laid. And then the lower right, you can see it being laid. Just a little view of how many cables, undersea cables, have been installed by year for internet purposes over time. And so you can see in the recent years, a lot has gone in. So there's a website you can go to. I apologize, I don't remember the name, but this is a high level view. There's a ton of detail. So website's very cool. You can zoom into a particular part of the world and see specifically all the cables that exist and who owns them and so forth. But its point is huge interconnection to connect all these countries together. So that's a little bit about the background about how it works. And so let's now talk a little bit about finding things and processing. So finding things, we talked about the Uniform Resource Locator, URL, and needs to find an IP address to. So when you type in google.com in your browser, how does it know where to find it? And then we all do searches, and how do we find information for searching? So there's a thing on part of the TCP/IP suite of protocols and rules is something called the domain name service. And I call that the internet's phone book. And it's basically, how do I find an internet address for something that I want to call? So you type in www.google.com, or in this case, medium.com, and it goes, your browser sends this DNS request to your router, has a little DNS server on it. It goes off and sends it down to a root level domain server, of which there are several on the internet. The root level, there's just a few, but there's all kinds of secondary ones. And so the root level looks it up and says, medium.com, I don't know where that, or I don't know that one in particular, but it's a .com. So I'm going to send a message back to your DNS router and say, well, you got to go talk to the .com server. So it then sends a request to the .com server. .com says, oh, I know Medium. That's over on this other server. So it sends that message to a secondary level server on the lower left. And it says, oh, I know where medium.com is. And it sends a message back, says, well, here's the IP address. It comes back to your local DNS and goes to your browser and says, well, if you want to talk to medium.com, you want to talk to IP address 104.16.121.127. The browser then sends that message, and the website at that location, that server, responds. All this happens in seconds. Is you type in google.com, it comes back instantaneously, or whatever, socialsecurity.com, whatever the website. So all this stuff happens at lightning fast speeds, but that's how the internet knows when you type in a particular address or an email address, and email is a whole nother topic, but again, it uses that same construct of there might be an email address at medium.com. And so it sends that request and gets that address, and then it knows how to actually talk to the device. So that's all occurring under the covers, so you don't see it, but that's how it works. And then we as humans, how do we find information? So there's general purpose search engines. You probably all used Google. Maybe you used Bing. Back in the day, you might have used Yahoo, and there's others. In fact, there was an interesting article in the Wall Street Journal last month called Search Engines That Respect Your Privacy. And these are some other search engines that work in different ways. The catch with Google is it's targeted ads. Every search you ever do, it remembers. And based on the searches you do over time and where you go, it determines, oh, gee, this person's always going to dog competition sites. So, oh, must have a dog. And so they'll send targeted ads. They'll order the results that you get based on people that have bought ads from them. And the other thing is based on your history over time, if you do the same search, you'll get a different answer because of things it's learned about you, places you've gone, and so forth. If you don't like that stuff, there's other things, these other alternatives or other search engines. Again, we don't have time to go into them all, but there's a lot of different ways you can search the internet where it's much more private. How does that happen? There's a thing, search engines basically have a whole bunch of computers, thousands and thousands of computers, and they have what are called crawlers, which go out and search the internet, look for websites, go through and look at all the web pages in that website and develop a base of information about every website everywhere on the internet. And so there's thousands of these things are running all the time, and it brings back that data and builds a database in the search engine. And that's how the search engine, when you type in a search, it goes and looks at its database and says, what have we seen where that covers this topic? And as an example, in my prior life, we would put up websites. And the catch with that is because of the millions of computers out there, these crawlers take time to find your website. So you put up a website and it might take a day or 2 or 3 for the crawler to hit your website, catalog all the information, load it into Google's database or Yahoo's database so that you can now search it. So anyhow, that's how search engines find information. And there's lots of nuances to this, but that's basically how it works. So finally, how is the information processed and provided? So there's lots of services out there. There's servers and there's enormous data centers spread all over the world that allow this to happen. So the services, here's some of the icons for companies that you know up at the top. There's this network, and then there's browsers and apps that are all using the network to get at these services. So there's servers. You've probably heard the term servers, and that's basically a simple computer, incredibly fast, no keyboard, no display, just a processor and memory. Most of them don't have disk because they said their storage systems are different. And you can see a couple different types of servers down there. In fact, the one on the right is what the latest version of a Google server is. And you can see they've made it even smaller, that they're little, it's a whole computer system on a little card that slides into that chassis. So then you take thousands and thousands of these servers and put them into racks, cool them, provide them power, and connect up the fiber optics, and they become these processing centers. And these are enormous processing centers, thousands and thousands of servers. I had a 45-year career in computers working for medium and large size companies. And I dealt with computer rooms that were 10,000 square feet, 5,000 square feet. I think the biggest one I ever dealt with was 20,000 square feet. But you look at these, and these are, these data centers have between 200,000 and 300,000 square feet. And you can see the lower, or on the one on the left, I believe that's an Apple data center. The one on the right is lower right is Amazon, no, sorry, Google data center. And I threw one on the upper left here. So many of you are probably familiar with the steel case pyramid. That was sold off years ago, and a company called Switch bought it, and they retrofit it, and it is now a large data center, and they're building additional buildings around it. And those those big cabinets are air conditioning that provide air conditioning to all the computers in that data center. So these things are enormous. They they demand or require an incredible amount of power. And so they have to be, the companies will look to find places to put them where utility data or utility cost is cheap. They do a whole lot in the case of climate change in terms of trying to have zero footprint in lots of different ways. Again, that's a topic in and of itself. And so just another piece of all this is, so if I have a server and there's people trying to access that server from all over the world. How do I do that and give good performance? And so there's something called a content delivery network. So on the left, in a case where there is no content delivery network, you see there's a single server out there. And in the middle there, you'll see 3 users, one based on the flags, one's in Russia, one's in Germany, and one's in the US. And if we're all trying to go to this server, and it looks like in this particular case, the server is in Russia, we all sit there and wait because that one single server is trying to serve up all that data to these people stretched across the world. So there's the time that it takes the information to flow, and then the contention of one server serving everyone. So in order to make these things work, they use what are called content delivery networks. So they take a copy of everything in their server and they place servers spread around the world so that if again on the right, you see they've now have multiple servers and they're copying data to them every night. And so in the middle there on the right, you'll see those 3 users now are making this request to the same service, and let's say it's Google. And now, while you saw weight, the spinning thing on the weight on their left-hand screens, on the right-hand screens, one's watching a YouTube video, one's looking at pictures, and one's playing music. And you can see with the clock, their response time is much better. And so in order to make all that work, here's an example of Google. This is the Google infrastructure that runs for when you type in a request to Google. So the blue lines all represent the fiber optic cables that are under the ocean that they own. And then you'll see a little blue icon, pin, I think they generally call those, and a green one. And they each have numbers in them. And so if you look at the green ones in the US, you can see Google has 2 data centers in Oregon, 4 data centers in the middle part of the country, and 3 data centers in the southern part of the country. Now they're going to add 3 more in California. They're going to add 3 more on the East Coast, and they're going to add 3 in Canada. But for right now, that's what they have. And you can see, look at all the greens, you can see they have all these data centers. And so when you type in a Google request, you might be serviced out of one of those 3 data centers in the East Coast if you're in Michigan. If they have brought them offline for whatever reason, you might go out to California. But somebody sitting in England might go to one of those European data centers, or if you're in Australia, you're going to go to their data center in Australia. So by making copies and having these enormous data centers, they can provide responsive information to people in all parts of the world. And so it's not a simple process. It costs millions and millions of dollars, but you can see here's what they do to make it all work. Last slide. I didn't want to end without at least talking about this. This is not, I've never been there, but as part of the internet network, there is a thing called the dark net. It's a section of the internet, it's multiple areas, but it's highly encrypted. You need a special set of tools to get there. But there's all sorts of nefarious activities that go on. Depends on the countries whether you consider it nefarious. So if you're in a country that has a very repressive regime, and you can get access to the internet, you can go to the dark net and be able to conduct business and do things where you can't be seen by others. So in privacy right of, in some cases it's privacy rights of citizens in countries that don't have the most friendly governments. You might likewise be protecting dissidents. In our world, it's more about computer crime. So when you talk about hackers, they live on the dark net. And on the dark net, you can buy all sorts of illicit and illegal goods. And the reason I know about this is because in my prior job, I had a computer complex that processed about 30 million credit cards a year. And my joke that Sue and I always have is that I can now sleep at night and I don't have to worry about waking up the next morning and knowing that somebody broke into all our credit card data and it's for sale on the dark net. And so you can go out on the dark net and you can buy, there's sites that you can bid on, and you can buy people's identities, social security numbers, credit card information, passwords. You've all heard about the various break-ins. Well, that data goes out in the dark net and people can can buy it. And so a person with a full set of identity with credit cards that have good balances and social security numbers, about $1 a person. So if you wanted to buy 10,000 of those IDs and passwords and credit cards, it's about $1 a pop. So anyhow, it's all about circulating network censorship. These things pop up and they get shut down and they pop up again, and they share inappropriate information. Other things, there's lots of other things. I don't want to go into it in so much, but I just wanted to let you know it's out there. So in summary, it's been amazing evolution over 60 years. It is by far the largest and most complex machine man has ever created. It facilitates information sharing on an incredible scale and with incredible speed. And at the same time, it's become now an amazing economic tool. While it was very much a research and business-oriented environment back in the day, now it is, we're all shopping at Amazon or pick your retailer, whatever it is you want to buy. There's many, many services out there that are available to you. So that's kind of a whirlwind tour. I'll stop sharing my screen here and then let Kim take over. Looks like we have one question.
Yeah. All right. So let's see. I'll start with the first one. Hold on here. From Don, how comfortable are you with the security of your smart home?
Oh, well, I am, it's a bit of a concern, but I keep my software up to date. I make sure my firewall is pretty tight. And the biggest thing is passwords. Is I use a password program. In this case, I use 1Password. So all my passwords are ugly. They're lots of characters and numbers and things I don't understand, and I just use that program to generate passwords and fill in passwords. And so all my devices, we make sure that we have strong passwords on them. And where possible, I use what's called two-factor authentication. So like in our investment site where our investments are, when I type in the ID and the ugly password, it comes back and sends me a message that I have to respond to. It gives me a code and I have to respond to it. And so there's all kinds of ways to set up your automated home to work in that fashion. I don't worry too much about my sprinkler system, but they're using good security practices is very, very important. You can't ignore it.
Right. Okay. Next one is a question from Ralph. It says, I'm limited to 25 meg attachments on Yahoo Mail, but on WhatsApp, it's unlimited, I think. So I can't send more than 10 pictures to someone in the US, but I can send many more to someone in Europe. Why is that?
So that's rules from that particular service. Just like even in Google, if you attach so many pictures and the file gets too large, they will convert it and use a different method. But yeah, all the email services, they have limits as to how much, how big or how many files you can attach. And when you hit that limit, you have to use another method. Something I use a great deal is called Dropbox. And that's a way to get around it. But there are arbitrary rules that company sets based on their servers and technology and concern about moving data around. That's why that is.
Okay. And then from Joan, with complicated long messages, how does the router keep the message in order and not transposed?
Good question. The router deals with each message individually. In the TCP/IP protocol, and when it breaks things apart and it sends those messages, they might, because of different routes, they might arrive at the other location out of sequence. That's what TCP/IP does. It waits till all the pieces are there and it reassembles them in the proper sequence. So down at the IP layer and moving it around the network, the packets all go independent routes and can arrive at different times. And then the TCP/IP part of that thing reassembles them into the right order.
Okay. Wow. Question from David. How physically delicate are fiber optic cable strands?
They are quite delicate. I mean, I'm always surprised they're strong, but they are delicate. In the cable, and again, if we were all together, I'd be passing them out. I don't know if I mentioned that earlier. So I have my little kit of demo samples. But anyhow, the cable itself normally has a piece of steel a steel wire that runs down in part of the cable to give it strength. And then when you install it, you have to be careful about corners. If you have a bite, sorry, not a bite. If you make a turn that is too tight, the radius is too small, you can cause damage to the fiber. So I know we installed, in my career, installed a lot of fiber. And when you worked with electricians and they put stuff in conduit, they'd always have to make sure they call it a sweep bend. So it was very gradual, so that when you pulled the fiber in, you didn't bring it around too tight of a corner and potentially break the glass. So it is an issue.
Okay. Question from Mark. Does the US government actually own any of the infrastructure backbone, or is it owned by private companies? And then do any general taxes support this, or is it supported by the ISP fees?
Good questions. So the government may own some of the backbone, particularly as it relates to in the security, FBI, CIA, those kind of people. But in general, most of the, I would say 98%, maybe more, of the internet, the backbone and so forth, is all owned by private companies. I don't know in different countries. That's more of a mystery to me. But the government owns very little as it relates to the backbone of the network. And then you mentioned ISPs. So ISPs, internet service providers that we connect to, like Spectrum or BPW or AT&T and so forth. Some of them are very small, not those names, those are all big names, but they can be a small, you could decide, I want to get in and be in my own ISP and set up something. I might not own any backbone, but I'm going to deliver internet access to local people. And so I have to make connections at either the local or the regional level. But again, if you wanted to get in that business, get in that business. But the government, I don't think they own very much, if any. Okay. And so their taxes aren't a play in there. Taxes would help support the research arm, the stuff that ARPA does, but so much now of the development is in the hands of others. It was just more in the early research that DARPA had a big play in it.
Okay. From Bob, with encrypted messages, how is the key to the deciphering the message transmitted?
Well, that's a hash class just by itself. There's all kinds of encryption methods. There's encryption methods where we have a shared key that people on both sides of the communications transmission have a key in their possession. And so it isn't actually transmitted, but the number of encryption schemes that exist out there that's never been an area that I've spent a huge amount of time, but there's a lot of ways to do that. And sometimes it's transmitted in a separate conversation. And sometimes it's just a lot of ways to it. So it's not that's not a simple answer. Yeah.
Okay, I guess we know what our next class is on. Let's see, from Gary, Google search engine is free to us because they're monetizing our data. How do other privacy protecting search engines make money?
So I don't know all the details. Some of them are, I'll call it shareware or not shareware, that's the wrong word. Um, uh, um, Open source and managed by research organizations. They choose to make money in other ways, and they provide that service. So it varies all over the map. But the reason Google has become so big is because they've been very effective at expedite or taking advantage of advertising. And there's a whole thing, I've thought at some point about teaching a class about the information organizations know about us and why, when you go to a particular website and all of a sudden you were out looking at Lowe's or Amazon at looking at some device or thing, and all of a sudden you go to some other website and up comes an ad for that thing that you looked at. Like, how does that happen? Well, there's an amazing infrastructure behind all of this that's not owned by, there's lots of people that participate in it, of how they take information they collect about us and use it to market us. I mean, that's a class by itself. So it varies widely. Sorry, I'm not giving an easy answer.
That's okay. Another one from Don. When do you use a VPN?
So VPN, it's called a virtual private network. And what it is, if you are concerned about security and the conversations and whatever it is you're doing between your computer and whoever it is you're talking to, or you don't want people to know who you are, you can set up a VPN. So that sets up an encrypted conversation between your computer and the destination that you want to talk to. And so I have a VPN service that if I want to do something and don't want people to know who I am, I can switch myself over to VPN. And so my conversation gets encrypted and goes off to this VPN service provider. And my message doesn't actually go out on the internet until it gets to that service provider. So it looks like my conversation is coming from them. They don't know who I am. Now, if I do, and so the point of, we always talked about in the business that we'd set up a VPN pipe. It's like a protected conversation from your computer to whatever computer you want to do at the other end. Like in the case of corporate world, when our employees would connect in from across the internet from a company provided laptop to our computer systems, we would install a VPN software on their machine, and their conversation between their computer and our computer systems was in a VPN encrypted tunnel. So whatever routers, wherever it went, nobody could see what that data was. It's encrypted. And so hopefully that explains it, but there's lots of ways, lots of reasons why I use VPN, but it's when you want to have a private conversation and you don't want people to see what you're doing.
Interesting. Okay. Another one is, who polices the dark web?
It's quite honestly, it's not really policed. A lot of very creative people. And so they'll make established connections. And because anybody can kind of connect up to the internet, you don't know what they're doing. And if they're doing it all through VPN or these other encrypted things on the dark net, you don't know what they're doing. And so there are security people that watch what's going on the internet, but there's a lot of creative people in the billions of devices on this network in various countries. And you think of North Korea, you think of Russia, you think of China, you think of countries that their laws are different. And so people can set up business and be on the dark web. And so it's very hard to police. And so therefore other people watch it, but they can't really stop it. And there's been very famous court cases of, there was, I can't remember the name, it's not the Silk Road, but anyhow, there was a very famous illegal site on the dark web in Australia, very famous. I apologize, name's not coming to me right here, but the FBI brought the lawsuit, extradition, guys in jail. And so there is some but it's not true. I mean, it's hard to stop because of the network is so big and so many things are happening.
Mhm. This might be another class as well, this question, I'm not sure, but it says you mentioned 11 internet managers, and this person's asking how they were established and how do they have power?
Oh, okay. So there's 11 organizations, 11 groups. There's the Engineering Task Force, IEFT, I think it's called. And they're the group that comes up with, for example, they're the group that so there's ICANN is another one. They administer all the names and numbers and addresses in the network. So, and it's sort of by mutual agreement of how they get their power. They've just decided the internet governing bodies decide, they, like I said, there's these 7 groups, they cover different topics. And it's just that organization collectively says, okay, you're going to do all the research. This group's going to do the research, and this group's going to do keep track of numbers and names, and this group is going to evolve the protocols and so forth. And so it's just by mutual agreement, and any one of these teams might have 10 engineering representatives or 20 engineering representatives from different countries. Again, many of these were established in the US initially, and there was a lot of drama, UN and whatever, about the fact that US had too much power over the internet. So now it's distributed, and Germany participates, and China participates, and Japan, and so forth. I don't know the members of all of them, but they'll come together, and when they want to do things on the network, they all bring security keys, and you can't turn on and do some of the things that they want to do unless they all plug in their keys and they're all checked off and everybody's here, and yes, we're going to mutually do this, and check, and away we go. So that's a topic in and of itself again. Sorry.
Right, right. We better be writing these down. Do providers pay usage fees to the owners of international fiber optic cables? How are these fees determined? And are there powerful new security strategies coming in the future?
So let's see, I'll try and answer it in 2 ways. So the owner of a cable will lease out capacity on that cable to others. And every company is different. Some companies will install the cable and say, I'm going to make money. And so they don't do anything on the cable other than lease it out to others. Others like Google, they put in the cable and it's for their purposes. And I honestly don't know if they lease out some of the capacity to others. So everyone's different. You know, you got 407 cables. They're probably a number of them are for the same company. So maybe there's 100 companies or 200 companies that do it. And so how their strategy for how they're going to use and manage the cable, everyone's different. There's something else you asked. Oh, the future. So the big concern, and this isn't just an internet problem, this is a computer problem, and it may not be in my lifetime, but there's a new computing technology called quantum computing. And these computers work very differently, but they're incredibly fast and incredibly powerful, to the likes of what we haven't seen. Now, we don't know if they're going to be around in for commercial use in 10 or 20 years. It's still very heavy research. But at that point in time, there'll be enough enough power that the passwords, no matter how complex we use today, will be can easily be cracked. And so there's a whole discussion about security needs to evolve, and there needs to be a better method. And so we'll see what happens there. Again, another topic in and of itself. And I'm not a quantum computer expert. I can talk to you anything you want about computers that run today, but I have not spent a lot of time studying that one. I'm not a quantum physics or quantum mechanics guy.
Okay.
So.
I think this is the last question. Do you believe Facebook is a benign service, or do you think users of Facebook are simply commodities? I'm not sure I want to know the answer to this.
Well, I'll tell you my personal opinion. I am not a Facebook user. My wife is not a Facebook user. Facebook is a great tool for connecting with friends. However, if you get your news from Facebook, you're not getting news. that is a mistake. And that's part of the division of our society, because there's a lot of rumor and innuendo. There's a lot of bad information on Facebook, and people who use Facebook as a source of news are making an enormous mistake. It's a great tool for connecting with friends, but there's an incredible amount of damage it's doing because of bad information that's out on Facebook. And so I have, as a personal policy, again, I've been doing this stuff wrote my first program 50 years ago. I've never been on Facebook. And if anything comes along that requires Facebook, I won't do it. That's just a personal opinion. So anyhow, I don't know if that answered the question, but that's how I feel.
Yeah, thank you. I think I've covered all of the questions that I can see right now. And then a couple of fun comments. Bill Wells said to you, gee, Dave, this all seems simple enough. I'm pretty sure there's sarcasm there. And then, of course, our very dear Peg Van Grau puts it so poetically, a compliment just saying to you, so knowledgeable, so articulate, so mentally nimble. Thank you, Dave. I think that wraps it up for all of us. Well said, Peg. Thank you for that. Gosh, that was a lot. You have to be tired from talking for so long. Although I have to say that was a really
that's what I know.
fast hour and a half. That just flew by. So thank you so much, Dave. Thanks everyone for being here.
Can I make one other
comment? We have a couple more classes for you to think about.
Okay. One other comment before I go.
Yes.
And that is relative back to the Facebook thing. And a lot of these internet services, if they're free, if the product is free, you are the product. That is a saying that my wife discovered and has commented on many times. And it's very true. Any of these services are free, they're making money somehow. Right. And if it's free to you, you must be the product. So they're using your data in some fashion. And so it's just a thought. So anyhow, sorry.
Yikes. Okay, it is 11:09, but if anybody wants to stay on to make any other comments or questions to Dave or Susan quickly, feel free to do that now.
Thank you for your time.
Yeah, that's great. Thanks.
Thank you.
I'm going to stop recording a minute.